Today we are going to work on lesson 5.7, which is on triangles and coordinate proofs. Don't get too worried about the word proof. We're not going to be writing the formal long proofs. We're going to be working with, how we can look at the coordinate plane and use the concepts that we already have available to us to prove that a triangle is. Today we're going to work on whether it's a right triangle or then, what kind of triangle is it based on its side lengths. All right, so we're not going to do proofs, but we're going to work on making a proof based on facts that we already have. All right, so how do we identify uh, if a triangle in a coordinate plane is a right triangle? Okay, um, so a right triangle by definition is a triangle that simply contains a right angle. Okay, so what we know are in a coordinate plane, right angles are formed by perpendicular lines. Okay. And we know perpendicular lines are formed by lines in a coordinate plane that have opposite reciprocal slopes. So to prove that a triangle in the coordinate plane is a right triangle, we're going to prove that two of the sides are perpendicular to one another, therefore forming a right angle, therefore forming a right triangle. Okay. So to prove that a triangle is a right triangle, when we're given information about it in a coordinate plane, we're going to find the slope of each of the three sides, and then we're going to determine if any of those slopes are opposite reciprocals of each other. Because if they are, then those sides are perpendicular. And then, the train of thought, if they're perpendicular, then they're right angles. And if they're right angles, then it's a right triangle. So that's kind of the process we're going to go through here. You have to have evidence and make it and use it to make your conclusion. You just can't look at it and say, hey, that's a right triangle or it's not. That's not the objective. The objective is to prove it, hence the proofs in the title. Okay. So here's what we're looking at. Determine whether the triangle with these given vertices is a right triangle. Now, guys, you may not have a coordinate plane to work with. All right. You just may have to use this information. Okay. What I did is I made a sketch of it here. So here's the triangle. Now, it may be a right triangle. It looks like this could be a right angle right here, angle R, but we don't know it for sure. And we're not guessing. We're going to prove it one way or the other. All right. So what we're going to do is we're going to find the slope of all three sides. And then we're going to look at those slopes to determine whether we have a right angle. Okay. So hopefully you remember how to find slope. So to find the slope of TR, this line right here, guys, if you have a graph for you, you can count, rise and run. If you don't have a graph and you're just working off of this, remember it's the difference in the y's over the difference in the x's. So 5 minus 1, negative 9 minus 5. Okay, that would give me 4 over negative 14, which is negative 2 sevenths. So the slope of RT is negative 2 sevenths. Okay, now find the slope of RI or IR. And again, if you have a graph, you could count. If you don't have a graph, you can always just do the old difference in the y's over difference in x's. So R and I, 12 minus 5, negative 7 minus negative 9. Okay, that would give me 7 over 2 because this would be a plus negative 5. So that's 12 plus negative 5 is 7, plus a positive 9, negative 7 plus 9 is 2. So the slope of RI is 7 over 2. And the slope of IT, again, difference in the y's over difference in the x's, 11 over negative 12. Remember, this is plus a negative 5, so that's negative 7 plus negative 5. And we would just write that as negative 11 over 12. All right, so I found all three slopes. Now let's compare them. Are any of the slopes opposite reciprocals? Remember, opposite means one's positive, one's negative. Reciprocal means as a fraction, they are flipped. The numerator denominator is interchanged. And what we can see is we got a slope of negative 2 sevenths and a slope of 7 over 2. Those are opposite reciprocals. Okay, so that means this TR slope and RI slope are perpendicular to each other. So therefore, angle R is a right angle, which means triangle TRI is a right triangle. That's the process we have to go through to prove that. Okay. And you can't do it by looking. It's going to take work here. All right. Another one. So DEF, is this a right triangle? Well, this gives us a look at it. It looks like FD could possibly be a right triangle. Okay. Sometimes looks are deceiving, and you may not have a graph, so you may not have a choice. You might have to go right into the work. All right. So let's find the slope of DE. That's the difference in the x's, 8 minus 6, over the difference in the y's. Sorry, difference of the y's, 8 minus 6, over difference of x's, 5 minus negative 3. That's 2 over 8, which is a fourth. Slope of EF, difference in the y's, 10 minus 8, negative 5 minus 5, 2 over, it's actually, it'd be 2 over negative 10, which is negative 1/5. And then the slope of DF is the difference in the y's, 10 minus 6, over negative 5 minus negative 3. And that'd be 4 over negative 2, which is negative 2. So there's my slopes. Now comparing them all, none of these slopes are opposite reciprocals of each other. Okay, so none of the slopes are opposite reciprocals. Therefore, there aren't any perpendicular lines. So there are not any right angles. So this triangle does not have perpendicular sides. Therefore, it's no right angles out there. And therefore, it's not a right triangle. So we're doing this all with slopes. Okay. Now, the second thing we're going to do in the coordinate plane is we're going to classify a triangle by its side lengths in a coordinate plane. All right. So, for example, here, we got to first of all go back and remember what our descriptors are. So, a scalene triangle is a triangle in which all sides are different lengths. Now, if all sides are different lengths, all interior angles are different measures. Okay. I'm just kind of throwing that in there as a bonus. But remember how I said in a triangle, the sides and the angle opposite are related. So if all sides are different lengths, all angles are different measures. Okay. An isosceles triangle, what we just got done working on, is a triangle, remember the definition, that at least two sides are congruent. All right. So in a isosceles triangle, we also know that at least two interior angles are going to be the same. And then equilateral, we know that's all three sides of the triangle are congruent. All interior angles are going to be congruent, which are all going to be 60s. We also can call this equal angular. It's called equal angular as well as equilateral. Those are interchangeable because of, we talked about the biconditional statement that made up the definition of equilateral. This is considered a regular shape. A regular shape is a polygon in which all sides are the same length and all angles are the same measure. So this would be a regular shape. And finally, equilateral triangles are actually also technically isosceles, because remember that isosceles is defined as at least two sides. So if you have three sides, you have at least two sides. So if it can be labeled equilateral, it can also be called isosceles. But obviously, we'd rather be more descriptive, which is this one. Okay. Now, how are we going to do this tonight, given ordered pairs as locations for the vertices of our triangle? It's all going to be distance formula. Okay. So this is all going to be, remember, this is our distance formula. It's the square root of the difference of the x's squared plus the differences of the y squared. And then simplifying that will tell us the distance. Remember, also in class, I told you it's if you have a coordinate plane to look at, you could use Pythagorean theorem too to find this, which distance formula is just a variation of Pythagorean theorem. All right. So this says classify the triangle by its side lengths, determine whether a triangle with a given vertices is scalene, isosceles, or equilateral. And now notice how this says check all that apply. In tonight's homework, you're going to have a box here that says, is it scalene, isosceles, or equilateral? The reason it says check all that apply is if it's equilateral, you would also check isosceles. Okay. If it's isosceles, it doesn't mean it has to be equilateral. So you just got to look at that carefully. Okay, so what are we going to do here? Well, I made a graph of it. You won't have this available to you, but I did it. And basically, what I'm saying is we got to find the length of all three sides, and then we're going to compare those lengths. So I'm going to do distance formula. Length of PQ. All right, the distance from P to Q is the difference of the x coordinates, 4 minus 2, squared plus the difference in the y's, -7 minus 2 squared. Okay. So if I do the simplifications and do the math, the length of PQ is the square root of 85. You don't need to find this as a decimal. Just leave it like that. It's the square root of 85. Okay. So I got that one. What's the length of QR? Now, you can do distance formula, or remember, if it is a horizontal or vertical line, you can't count. So 1, 2, 3, 4. QR is going to be 4. I just did the distance formula to show you what happens. You get 4. All right. And then we need to know the length of PR. Again, it's distance formula. So it's difference in the x's squared plus difference in the y squared. And if you do the math here, you get square root of 85. So what you notice is, of my 3 side lengths, 2 of them are the same. So because we have one pair of congruent sides, this is an isosceles triangle. Okay. It's isosceles. That's how we do it. Okay. Another one. Got triangle ABC located at these vertices. We want to figure out, is it scalene, isosceles, or equilateral, just by looking at the coordinate plane. So here's a graph of it. Okay, now let's go over here and do the work. The distance from A to B, difference in the x's squared plus difference in the y squared, and we get square root of 41. Length of BC, difference in the x's squared plus difference in the y squared. We're going to get 6. So evidently I could have counted that one. Look here, BC is vertical. I could have counted that one. Length of AC, right? A coordinate, C coordinate, difference of the x's squared, difference in the y squared. We get square root of 29. So they kind of looked at the drawing. They kind of looked like they all could be the same length. Winds up is none of them are the same length. All right. So this is a scalene triangle. So that's the process. So this is the work you need to do. All right. So you have to support your answers. All right. You have to show how you know what you know. That's why it's called a coordinate proof. The proof is the distance formula, or the finding the slopes to prove things are perpendicular or not. That's the proof part. Okay. So that's the homework in Alex. You're going to have to turn in the work that proves your answers. So you're going to have to write things out to prove it, whether it's distance formula or slope, like I talked about. All right. So get to that homework. Make sure you get it done. Make sure you have proof to go with your answers. Then you're going to turn that in, and I'll let you have at it.